welcome to lecture number 62nd, and we have been discussing the network analysis using graph theories. And in the last 3 lectures, we have defined several important things. One is a matrix A, which is called the incidence matrix. Let me very quickly go through it. Incidence matrix. Incidence matrix is can be easily constructed by going to each node and writing down the +1 or -1, 5, 6 like this. And here, for example, go to node A, node B. These are the 3 rows. Node A, things going out is assigned plus sign. So, 1, 4, 6 are the participating elements while writing down KCL here, and it will be 1, 4 and 6 all are going out. So, 1, 4 and 6, others are 0. Similarly, go to node B, things going out will be assigned plus. So, 3 is plus, 2 and 4 coming into junction B, and they will be minus 2 and 4 for node B, others are 0. This I am showing how quickly you can write this matrix looking at the graph of the network. And similarly, at node C, things coming out is I 5. So, I 5 will be +1, 3 and 6 are coming in. So, 3 and 6 are coming in. So, this is how easily this matrix, and this is the reduced order incidence matrix. We are not writing down KCL at O, because that is not going to give you any new equation. And also we discussed about the size of the matrix. But at the end, what was the implication of this? If the branch currents, which I am not showing, the arrows means the branch currents in this direction, and also the voltage of this branch is VE4 with this side plus, this side minus, inconsistent with the direction of the current assumed. Therefore, we found that A into IE is the Kirchhoff's current law equation, that is equal to 0. This was the finding with the incidence matrix. Similarly, we tried to express the element voltages in terms of the node voltages. So, we defined a node voltages which is a column vector V A 0, V B 0 and V C 0, and we found that the element voltages, that is V 1, V 2, V 3, a column vector E 4, V 5, V 6. This vector, which I was calling it as matrix C, and we also note that this A transpose element voltages are there. This is the thing, and then we have to find out the element voltages, like this column voltage was shown to be equal to A transpose into the node voltage. That is what we have seen last time. So, these are the 2 equations which involves the A or the incidence matrix. We found out that. Okay. Similarly, then we defined what is a tree of the network, what is code tree of a network, what is twigs, what are links and so on. Then we found out in our last class, which I will just quickly go through this one, no point in repeating. And we first draw, this is the tree, we drew, this is the graph, full graph. Then from that we just chose one tree like this, that is the firm blue line, and then we with the dotted red lines are the links, and then for each link, if you put one link, then a closed circuit will be formed, and we wrote down the KVL equations in these three fundamental loops. What is a fundamental loop? Fundamental loop is one where only one link will be present. For example, this is a fundamental loop. Is this a fundamental loop? No, two links are present, although KVL will be satisfied there, but we look for the fundamental loops where there will be only one link present and it will form a closed circuit. So, like this one, it is a fundamental loop. Similarly, this is also a fundamental loop, and this one go like this, this also a fundamental loop. Why? Because there is only one link 6 present. Then we told you that the first equation is this B into V is equal to 0, which is nothing but the KVL equations. If you write it here, KVL equations in fundamental loops. Isn't it? B into V is the KVL equation in the fundamental loop. In fact, this I did here. For example, in the fundamental loop, say loop 4, this is mere naming, is not the fundamental loops are 6 in numbers. L4 is one fundamental loop where link 4 is only present. L5 is another fundamental loop where only link 5 will be involved, and so on. And then I told you that while writing down KVL equation in these fundamental loops, you start your journey. First write down the voltage of fundament of the link here, and that whichever direction it is, you call it E4. So, E4, then minus E2 minus E1 equal to 0, etc. Similarly, for 5 it will be this E5 you assign plus, then this is also plus, and this is also plus. Like that, the third one is E6 minus E3 minus E2 minus E1. So, this matrix was B into V is equal to 0, that is what I was telling. So, the equation involving this one incidence matrix is over. Then we that is what we call the tie set matrix. So, this is incidence matrix. Tie set matrix was defined as B, and for that you have to form the tree and etc. And then these two equations were obtained. V into V E is equal to 0. This is the KVL equation in fundamental loops. And also the link currents was B transpose into you know to relate the link currents and the element currents. So, B transpose into I L, B transpose into I L is equal to I E. These are the another two important equations, these two, which involves tie-set matrix B. What is this I L? You should be only careful. Once we have decided about the fundamental loops, assign the loop currents. For example, this is the fundamental loop, this is I L 5. Okay. What is the direction of I L 5 chosen? Along the direction of the link current. Because it is a directed graph, I know this direction, it will be like this. Similarly, in this loop, this link current is I L 6, loop current, and for this loop current is like this. So, we applied KCLs and found out those relations. From this we got this particular relation. Generally, we will show you that this particular A matrix will be utilized, these two equations, while solving circuit by nodal method, Why? Because in node methods, we find out write down the KCL at different nodes, that is this one, and then we try to find out the node voltages, is not, which is V n, this vector V A 0. So, this equation will be necessary. Similarly, this method will be utilized, this tie-set matrix, to solve the network problems by loop equations. So, I have to write down the KVL equation B V equal to 0, and then I have to find out the loop currents using this one. I must relate loop currents with the element currents, and about the dimensions I have already told you. Now, today what I am going to tell you is another matrix, that is why it is not going. That is called a cut set matrix. This is also very interesting. Cut set matrix, which will be denoted by Q. We defined A, we defined B. Now, another thing is called cut set matrix Q. Now, these equations are perhaps will be totally new to you. Other earlier two things were only we involved the KVL, KCL, etc. from that. Here also similar things I will do, but the idea is slightly different. It is once again writing down KCL only, but KCL not at nodes where the KCLs are written. Acha, to get the idea clear, we know that suppose here I do some rough work which I will erase. Suppose you have a network like this. There are resistances, maybe voltage sources. Try to get a feel of what I am trying to do. Here is a resistance, here is some voltage, what not, and there is also some resistance. It is a network, okay, with these are the nodes. Now, in this network, we always apply KCL at the nodes, that is fine, no problem. But it is once again KCL in a larger perspective. What I mean by this? For example, if I say there were some wire going like this, which is carrying a current I 1. There is another wire carrying a current I 2, and there is another wire carrying a current I 3. These are part of some network element currents. In some 3 branches it is like that. Now, this point is important. Suppose you imagine there a line here, there is a line. Here there is no junctions I 2, I 1, whether they have made a junctions or not, I am not sure. But if you can imagine a line here, then the current crossing this line will sum up to 0 once again. What do I mean by this? That is, current crossing this imaginary line from left to right is I 1. This branch, only these 3 branches are involved by this line, suppose, and then I will say this is minus I 2, no, plus I 2. Current going from left to right, I have assigned positive sign. So, I 1 plus I 2, and then minus I 3, this will be also 0. Although, so current crossing a line will also, those currents summed up with due regard to their sign, left to right or right to left, whatever it is, that will also add up to 0. Is there a junction here? No, not a junction, but still this is called KCL in a broader perspective. What is the implication of this? Implication is very clear. Suppose you say that in this network you draw a line like this, divide this networks into 2 halves by this green line, suppose you have set up. Then I will say that if you have solved this point, you listen carefully. Suppose after solving the network you find this is I 1, this is suppose I 2, and this is suppose I 3, and this is suppose I 4. So, I have divided the networks into 2 halves, as if by drawing a line, you can cut the network into 2 halves, cut. Then I will say that in this line several branches intersect, this branch, this branch, this branch, and also this branch. Suppose we have solved the networks and the currents were found out to be this is I 1, this is I 2, this is I 3, this is I 4. Then what I am telling that suppose left to right I am telling positive. So, I 1, this line from left to right I 1, but this is I 2 right to left minus I 2. Then this is also crossing this surface from top to bottom. So, in the same sense as that of I 1. So, plus I 3 is not, and this one is crossing this from this side to this side, because this is the arrow I have put. So, that will be minus I 4, that will be equal to 0, has to be 0. That is the interesting part of it. Therefore, if you imagine an imaginary line dividing the whole network into 2 parts, you should not draw a line like this and say here also KCL will be satisfied. Suppose I have not extended this line, only I stopped here, that is this current and this current will sum up to 0. No, you have to take the line so that it divides the full network into 2 halves. Partly you should not take it. Okay? It is expected to be, because any line whatever current goes in must somehow go in from left to right or from this side to that side, same amount of current must cross the other way round. Okay? Otherwise, there will be accumulation of charges and so on. So, so this is the basic idea of this cut set matrix writing equation. It is also basically involves KCL not at nodes, but at some line which we call cut set or sort of thing like this. For example, in this network, this is the network, its graph is like this. If somebody divides the network in this way, draw a cut set, this is called a cut set, that line cut set. Then I am sure about one thing, this you try to follow me, I 6 from left to right it is crossing this cut set. Suppose this you assign plus sign, then I 3, these are the 3, 1, 2, 3, 4 elements are involved here. It will divide the network into 2 halves. So, I 6, then plus I 3 this way. Then should I write plus I 2 or minus I 2? Minus I 2. Why? Because it is crossing this line in the opposite sense as 6 and 3 did. So, minus I 2, and what about I 1? This is the current. So, plus I 1. This must be also 0. See, I have not applied KCL at the junctions, because I 6, I 3, I 2, I 1 they are connected to different nodes, but the fact is this has to happen. Got the point? This is the basic idea of what we are going to discuss about the cut set matrix. Okay? So, any cut set, this is another cut set, one can draw a cut set here. Then the currents involved will be 6, I 6, I 4, I 1, I 2 and I 3. I can write down the KCL equation. Suppose you draw a cut set like this, then I will say that I 6, suppose assign plus sign there, I 6 plus I 4 plus I 2, I 2 and minus I 5 is equal to 0. I think you have got the idea. Achha. Now, with this background, I will now go to next page and hopefully that is the figure I will be needing. So, suppose this point was A, this was the network. Now, the fundamental cut sets are those cut sets where there will be only one tree element involved. First of all, what you have to do is this, you have to draw a tree of this network. So, let us draw, and the same tree that I took earlier, I will take that tree. It is a tree, because all nodes are taken into account and there is no closed loop existing, and this was 1, this was 2 and this was 3. And where are the, so these are what, twigs. So, 1 element 1, 2, 3 are twigs, and this dotted lines are the links. So, this is blue line twigs and the dotted lines are element 4 with this arrow, this 6 and this 5. So, 4, 5, 6 are links that we already know. Now, and these are the nodes. Okay. Now, what is a cut set? That is, you draw a line such that the network will be divided into 2 portions, where on the other side there must be at least one node. You can easily understand. So, you cut this network by any way, this way, that way, we will see that. But the rule is the fundamental cut set, we call it fundamental cut set. Cut set are those lines which will break the networks into 2 parts, where there will be only one and one link present. Only one and one twig will be present, I am sorry. So, I will divide this network into 2 halves, so that there will be only one twig present. For example, I will say that I will divide this by a line like this. Take a scissor, think I have divided this line. Is it a fundamental cut set? Yes, it is, because it divides the network into 2 halves. Okay, fine, there is one node at least present on the left hand side, those things are there. And not only that, this cut, when you cut it, it will only involve one twig. Twig number 1 will be involved. Suppose I take a cut set which will divide the network in this way. It will also be a cut set, no doubt, but will it be a fundamental cut set? The answer is no. Why? Because although it divides the networks into 2 halves, but only one twig is present is not satisfied. There are all the 3 twigs are involved while considering this. So, this is not a fundamental cut set, not a fundamental cut set. Therefore, I will say fundamental cut set is one which will involve one and only one twig, one and only one twig. So, this is a fundamental cut set. Got the point? Therefore, so let me redraw this. This one you just copy and then paste here. So, it is there. So, here in this diagram I will only draw the fundamental cut set. How many fundamental cut set will be there first of all? As many tweaks are there. So, that is the thing. So, I will erase this thing, because after all this is not a fundamental cut set. Forget about fundamental cut set. Then you say that so this is fundamental cut set and I will call it cut set 1. I will give a name cut set 1. How to draw the other cut set? This was 2. Can I draw a cut set involving only tweak 2? Yes. This is the cut set and this cut set I will call CS2. Whichever tweak will be involved, by that I will call that cut set. So, cut set 1 means it will involve tweak number 1 only, others will be links. Similarly, here is a cut set 2 which will be like this, and there will be a cut set here. I can draw a cut set. What name should I give? This tweak 3 is involved, so cut set 3. Okay. So, these are the 3 cut sets, fundamental cut sets possible. Then what we will do is this, we will write down the KCL at these 3 nodes involving at the cut sets. So, writing KCL at cut set will be our next job. So, write down KCLs at the cut set lines. Which is very easy to draw. Come to this cut set 1, KCL at cut set 1. It will be CS1 only, do not think about CS2, CS3, only CS1 is there. Then you see only one tweak, that is tweak number 1 is involved. So, this current direction you assign plus sign. So, I1, IE1 is not from this side to this side. Similarly, I4 is from this side to this side. So, plus IE4 plus IE4. Similarly, IE6 also crosses from left to right. So, plus IE6. That is all. This is the 0. Go to cut set 2. Cut set 2 it is? Yes, cut set 2. Here I will apply once again KCL at this cut set, at this line, not at the nodes. What it will be? Which tweak is present in this cut set? Only 2, that is to be 1 tweak 2. So, from bottom to top is the positive direction. So, IE2, that you first write, IE2, that is from this side to this side, IE2 is flowing. Similarly, IE4 is in same way, it is crossing the cut set 2, and similarly IE6, this must be equal to 0. Finally, KCL I am writing at cut sets. CS3, cut set 3. what will be the KCL? So, here is the line. So, 3 is crossing, 3 is the twig which is involved here. So, that will decide the plus minus thing. So, from left to right it is crossing, I will say I E 3. What about I E 6? It is also from this side to this side as I E 3 did. So, that will be also plus I E 6, plus I E 6. And this one is the other way, it is crossing I E 5. So, minus I E 5 and that will be equal to 0. Got the point. So, this is the KCL at the cut set. So, there was a correction here because I missed this term, okay, I E 5 while writing down the cut set 2 KCL equations. See, cut set 2 is this one. Which currents are involved? I 6, I 4, I 2 as well as I 5. So, that I missed. So, it will be minus I 5. Please note that, which I have put it with red inks here. Okay? Thank you.